My name is Michael Puruganan. I'm a Silver Professor of Biology here in the NYU New York campus. And I also have a laboratory at NYU Abu Dhabi where I've been involved with for more than a decade now. And I have the pleasure of serving as the academic director here at 19 Washington Square North. So over the academic year, 19 Washington Square North is hosting numerous activities, lectures, conferences, workshops, all to help inform the public and the NYU New York community as well about things that are happening in the world. It's also a place for the public to interact and to learn. A key partner of ours here at 19 Washington Square North is the NYU Abu Dhabi Institute, which is led here by its Director of Academic and Research Programs, Sharon Hakaken-Bergman, who unfortunately isn't here today, and her staff, who organizes many of the activities we have here. And so this includes this activity we have here today. So today we're very, very pleased to see all of you. This public lecture on the natural history of the Emirates given by one of our faculty at NYU Abu Dhabi, Professor John Burt from the program of biology. John has been a colleague of ours since the beginning, being one of the first faculty members to join the biology program of NYU Abu Dhabi, to join NYU Abu Dhabi itself. A native of Canada, he did his undergraduate at Cape Breton University and MS and PhDs at the University of Windsor. John is a marine biologist who uses the Arabian Gulf, the world's warmest sea, as a natural laboratory to understand how marine organisms respond to and cope with extreme environmental conditions and to provide insights into the potential impacts of future climate change. With projects on corals, coral symbionts, reef fishes, mangroves, and seagrasses, John leads a diverse team of researchers deepening our understanding of the marine biology of the Arabian region, with projects ranging from genomics and molecular ecology to physiology and ecosystem-level processes. In addition, John and his team continue to use science to support locally relevant policy, management, and conservation practices. John chairs the Mideast Coral Reef Society and is a council member of the International Coral Reef Society. Within the UAE, John is a member of the Mohammed bin Rashid Academy of Sciences and is also the lead of the Climate Change and Terrestrial, Marine, and Freshwater Ecosystems Research Cluster in a climate change research network for the UAE Ministry of Climate Change and Environment. John was awarded the 2017 Sheikh Mubarak Al Nahyan Award for the Natural History of the UAE for its continuing contributions to the enhancing of public awareness of the marine systems of the Emirates, and was also awarded the Transformative Research Award in 2022, which is the highest research award of NYU Abu Dhabi. I must add at this point that he, together with Mary Kililea, who's seated right next to him, then of Biology and Environmental Studies and now at the School of Professional Studies, was among the first 19 Washington Square North Fellows here at this facility back in 2020. One reason we're all here is that last year, Springer Nature published a book, A Natural History of the Emirates, of which John was the lead editor. And you can see copies of the book right there. This is a fully open access comprehensive resource written for the public that discusses nature in the Emirates, and today we will hear something on that topic from John. So again, it's a pleasure to welcome you here, and I know we're competing with the bright sunshine outside, but I'm glad you're here to listen to the natural history of the Emirates. And let's welcome to the podium Professor John Burt.
Thank you, Michael. Thank you all for being here. I also agree that it's hard to capture people on a beautiful day like today. You can see spring is coming. Just for some background and context before we get rolling on this, as Michael mentioned, I'm Canadian. And so I grew up, my father was a school teacher and my mother was a homemaker. And my parents would drag us out, for example, winter camping for several months a year, cross-country skiing and things like that. And although they had zero money, they also had a sailboat, and we would basically hop on that sailboat as soon as school finished and go for 2 months until we had to get back to school at the end of the year. And what that instilled in me was a real appreciation for nature and the environment and a love for the outdoors that I carry on today. And so, as Michael mentioned, my research focuses on marine biology. So we'll discuss this a little bit more later, but the Arabian Gulf is the world's hottest sea every single summer. And so if you're interested in understanding how marine organisms, be they fish, corals, other organisms, how they cope with and respond to extreme environmental conditions, what this might mean for other organisms in the tropics as we go forward with climate change, that's a fascinating place to work. So that's my sort of academic hat that I wear all the time. But I take off that hat occasionally and put it down and wear my more passion for the environment hat. And that's what I'm here to talk with you about today. So this is a project that became a passion project during the pandemic, well, alliteration. I'm going to introduce you a little bit to some of the things that I've learned about the UAE and that we've put together in this book. Now, many of you may be familiar with the Emirates. It's quite a small nation. It's only about 700 kilometers wide by about 300 kilometers from north to south. And it's relatively young. So it was only federated in 1971, so just over 50 years old. Yet we're now familiar with the Emirates as this sort of nexus for cultural exchange with this amazing architecture that is supporting this population that we have here that's gone from just over 100,000 people in the 1970s to today, 10 million people and continuing to grow. And so it's had rapid development and expansion of this trade, but we also have this equally important need for the residents, which make up 85% of the population is residents like myself who are expatriate, and the other 15% who are citizens, to gain an appreciation and knowledge of these ecosystems, these organisms that are uniquely adapted and resilient to the extreme environmental conditions that we have there. And so what came out of my pandemic project was, as Michael discussed, this 750-ish page book called A Natural History of the Emirates, which is a free and fully open access book. So there are hard copies that are available if you're into that sort of thing. But we intentionally made this as a resource that's available to the general public around the world who are interested in the Emirates. So it's being widely used in the environmental consulting industry, for example, as well as the school resource and so on. Just a little bit of the history of natural history in the Emirates. So functionally, there wasn't really much known about the sort of pre-industrial Emirates other than materials that were collected in the 1800s by folks that were coming in mainly with the British military. They were coming in, documenting what organisms they were seeing, taking collections, and then sending them off to the London Natural History Museum, for example. And so we didn't really have any homegrown knowledge on what was there in the Emirates and what the environment was all about. This started changing in the mid 20th century when we had the discovery of oil and then the establishment of more of the Brits mainly, but also Americans coming into the system to sort of set up the burgeoning oil industry. And what you had happen is these folks are moving into these countries that are really rapidly developing, but we know nothing about. And every weekend they finish doing their geology for the week, looking for oil deposits, and they go off and explore with their Land Rover Discovery. And so a lot of the early information that we have that was recorded history of the area actually comes from people who are amateur natural historians. So people who are geologists working on botany or working on coral reefs. So for example, Kinsman in 1964 wrote a paper in Nature. He's a geologist, but wrote a paper in Nature about the corals in Abu Dhabi being the most heat-tolerant corals in the world. And so even today, this is well before we started talking about climate change, of course, but even today, we're still referring to those original papers. As the economy and the system in the UAE developed, we started expanding out. We had the establishment of the Emirates Natural History Group, again, largely made up by people who were amateurs working in other industries, but doing this out of passion. They started in Abu Dhabi and then branched over the next few years into Dubai and Al Ain and various other cities across the Emirates. And started actually developing a journal that's still here today called Tribulus, which is named after one of the most common plants in the UAE, and which continues to be published today. And it wasn't until 1977 that we first started getting professional researchers on the ground. So that was when the UAE University was established in Al Ain. And then over the subsequent decades, we started seeing other universities established. Zayed University, the higher colleges of technology, and later in 2010, New York University, Abu Dhabi itself. And so there's been exponential growth in the amount of research that's going on in the UAE and our understanding of this system. But really, it's been largely driven by amateurs in the past, and most of our knowledge, around 85, I would guess, or 90% of our knowledge in published literature is actually coming from amateur natural historians who just have a passion for the environment and are out there being weekend warriors. So it's a fascinating place to work. And the discoveries that were started by the amateurs continue to this day. So one of the people who fund my research is Dalio Philanthropies here in New York. They have one umbrella organization called Ocean X, which goes around the world doing ocean-based research. And so you can see me on the left-hand side of that submarine going down. This is in December of just last year after COP28, where we got to dive from anywhere from 125 meters down to almost a kilometer depth in these submersibles, exploring the deepest parts of the UAE that we had no idea what was down there. There's never been any research done on the east coast of the UAE. We discovered, for example, you can see this mesophotic coral reef that's over here. So this is called mesophotic because it's at depth where there's virtually no light. So this reef here is at 148 meters. And when you turn off the lights in the submarine, it's pitch black. Yet we have diverse, abundant coral reefs in that area that we didn't even know existed, and are home to species that we know are new to science, let alone new to the UAE. And so we're working on that project now. We also discovered this bramble shark that you can see over here. This is the first record of this shark species for the Emirates. There are lots of them out there. We just have never seen them because they live basically deeper than 600 meters depth. But there are tons of them out there. And so we've been cataloging where we've seen them and how many of them, and they're various different sizes. We've also discovered this picture here is actually mangrove roots that were found at 125 to 150 meters depth. So we're actually seeing the coastline at the last ice age, way offshore from the UAE in the Indian Ocean. So really still a lot of developing knowledge going on in the Emirates with the help of organizations such as Ocean X. The book we dedicated to a gentleman named Peter Hellier. He's an institution in himself in the Emirates. He lived there for over 40 years and was the person who set up the Emirates Natural History Group and then Tribulus, the journal of the Emirates Natural History Group, like I said, still being published today. He sadly passed away just as this book was being published, but I thought it would be nice to put him up there because one of the inspirations for this book was actually his book from 2005, which is now out of print. But it, laid the foundation for the work that we did in putting this book together. But the real inspiration for the book was our students at NYU Abu Dhabi. So we have there roughly 2,500 students who know nothing about the Emirates. And they're coming from 125 nations around the world. And they mainly stay on campus and go into town and have little recognition of the amazing diversity and mosaic of ecosystems and organisms that we have across the Emirates. And so really this project started during the pandemic as me thinking through what would be something that I could give to the students that adds value to their knowledge about their host nation for 4 years. And this doesn't just apply to the expatriate students, which make up 85% of our students, but the other 15% are Emirati citizens who also surprisingly have very little knowledge of the ecosystems and the organisms and the environment of the UAE. So this has been pulled together for them, and we wrote it intentionally for sort of an educated lay audience who just want to learn about the Emirates. So every chapter in there has been written for the general public, and it's supported by over 450 color images, giving sort of illustrations of the amazing variety of life that we have across the Emirates. So what I'm going to do today is basically walk through the first couple of chapters of the book to give you a teaser or a taster, and then you can go and read the rest of the book. Like I said, it's fully available online for free for those of you who are interested in learning more. And I see we have ex-students here, employees that worked at NYUAD, as well as people who've never been to the Emirates but have an interest. So welcome. So I'm going to talk a little bit first about the physical setting of the Emirates. And the reason I'm starting with this is when you think about it, the physical setting of a place is what structures life. So it's sort of the stage on which the play of life draws out. And we'll start first by looking at the geography of the UAE, because the geography of this area is extremely important. So as I mentioned, the UAE is relatively small in terms of its size. You can see it's largely dominated by sandy deserts here, but we have these various other systems that we'll go into. And it's this mosaic of different systems that provide the microhabitats that allow different diversities of life to form and those environmental conditions that you have there. So when you think about geography, it's not just your location on Earth, it's the slope of your sediments, the type of materials that make those up, the chemistry of them, and how that drives life. Things like climate also play a role, humidity, rainfall, temperature, et cetera. And then even the vegetation serves as part of a geography of a place, all of which structure the type of life you see in these different locations across the UAE. And so when we're looking at the UAE in terms of its geography, we're talking about four principal areas. So the ones that you'll be most familiar with will be the large sandy deserts, but they themselves are actually quite diverse. And we'll go through a few examples of that. We've also got the large coastal strip that runs along the edge of the Arabian Gulf or the Persian Gulf, depending on where you're from, you call it different names. We also have on the east coast of the UAE against the Indian Ocean in the Gulf of Oman, a large series of mountains that we'll discuss, and then some alluvial plains, so the sediments that run off because of erosion into the surrounding environments. And so this is a teaser for those different ecosystems, and you can see the diversity of habitats just in these four images here, from the deserts to the mountains, the coastal plains to the mountains, to the sandy deserts, and to the alluvial plains next to the mountains. So in terms of the coastal plains, these are a very low-lying area that basically goes from the coast itself of the Arabian Gulf and extends in about 30 or 40 kilometers from the coast itself. And when you're looking at that coastal area, you'll see that large areas of it will be made up by these white sandy beaches. They're made of carbonate shells, a hash basically, so broken down marine organisms that give it that beautiful white color. And this extends from Dubai basically all the way to the north of the country. Further west in the country, in the far regions towards Qatar, you'll see massive salt flats that extend for many miles inland. So we have the second largest salt flats in the world in the Emirates. Most people aren't even aware of that, but they're an amazing resource for geologists because that's, when you think about the origin of oil, that's what you look at. We have massive lagoon systems across the UAE, which are a biodiversity hotspot because of the shallow nature and the mosaic of multiple ecosystems that they contain, including things like mangrove forests. So the only evergreen forests in Arabia are mangrove forests, and incredibly important in terms of biodiversity as well as carbon sequestration. And then we even have weird things like fossilized dunes from earlier wet periods of the UAE. And then the rocky outcrops that extend into the sea in the northern parts of the coastal plains.
Can you tell us the sentences about fossilized dunes? Like, what is it?
So these dunes here were formed basically during, it would be probably late Miocene. So this whole area was very wet. There's actually rivers running through it at that point in time. And so you can actually drive out a couple of hours from the capital city of Abu Dhabi, and you'll be able to see these things, rocky outcrops all over the place.
Were done by water, not by wind.
Correct, done by water, yeah. So sedimented by water. So they were underwater at some point. So they were formed by wind, then sea levels rose, froze them in place through lithification. So they cemented them up. And then when sea levels left, they stayed in place. So they're eroding now just because of the wind, but they're still in place. So the sandy deserts, as I mentioned, are the largest component of the UAE. And when you're looking at this map, you can even see there's differences in the variation of these sandy deserts. So you've got these massive sand dunes that are down here at the edge of Rub al Khali, which is Arabic for the empty quarter. So when you think of your classic desert movies with the guys on camels going through, that's where that would be filmed. Then you've got areas like over here where when they filmed Star Wars, was filmed in slightly smaller dunes because they're a little bit more manageable, and so on, extending all the way up the coast until you get to the mountains over here. And so just looking at a few examples of this, your classic deep deserts near the Rub al Khali will have sand dunes that are sort of this sort of size and extent, very large, massive, interesting to wander around on. And you'll notice that the sediments in those areas are often sort of a reddish color because it's actually erosion of quartz off of central Arabia, which has been rising as the Arabian plate has ripped off from Africa. So that's erosional, and it's turning red because there's iron in there, so it's rusting functionally. It gives you that iron color. Versus the coastal dunes, which, as we mentioned earlier, are white because they're largely made up of shell hash. So as you go from the center of the country towards the coast, you see this transition in the color of the dunes as well. And as you get up towards the northern Emirates, against the mountains that you can see in this sort of area, this is what the dune systems look like. Bit more vegetation because there's more rainfall because of the mountains, but you can also see there's this dance that's going on between the mountains and the sand dunes. So right now we're in a period for the last 5,000 years. It's been extremely arid in this region. But before that, it was what was called the climactic optimum in human civilization, where this whole area was actually quite wet and it was a savanna system. And so we'll talk a little bit more about that later. And so this is the empty quarter. These are the classic sand dunes that you'd see in that area. They extend up about 150 meters in height, and so really quite high, very dangerous for driving if you get trapped on the wrong side of one, if you're doing some off-road driving. But you can see in the back of them, the sand dunes will come down and hit these sebkha systems, the salt flat systems, and then rise again. And these go on for all the way into Saudi Arabia for a long, long distance. Every year, we read about people dying because they've decided to do that drive, and then they get trapped. And there is zero water that's out there. But you can see that when you get down into the salt pan at the base of these dunes, the freshwater system is actually quite close to the surface. So when you think about your classic movies with oases in them, this is where the oases form. So there's a big oasis called Liwa that's near Abu Dhabi, for example. And it's because this lens of fresh water is sitting right there just below the surface of these salt pans that are in between the sand dunes. If you leave those big dune systems, you get into sort of the coastal plains as you get closer to the coast, and then eventually to gravel plains where you can see Barkan dunes, these sort of crescent-shaped dunes that are actually mobile and they're moving around all the time with the wind. Further towards the north, near the mountains, you'll see these clusters of trees, these copse of trees. They're called gaff. It's the national tree of the UAE. And these were a tree that during the humid periods would have been across the Emirates because it was a savanna system and there was enough water there to support all of the vegetation in those savannas. And what you're seeing now are vestiges of those. The only ones that are left are ones that are very close to groundwater, and the rest have died off. So you will see them patchy in nature. And then the sands eventually grade into stuff like this where they're sort of running into the mountains, and you get these little rocky outcrops with unique geology that give you very distinct floral diversity, for example. And again, more vegetation because you're getting close to the mountains and the rainfall. So in terms of the mountains of the UAE, this is a map showing some of them here. So this range here is called the Hajar Mountains, and that extends down into Oman for several hundred miles further south. And we're really sitting at the lowest elevation of the whole Hajar range. So here in the UAE, the mountains are typically around 1,000 meters at maximum in the Hajar mountain range. And as you go further south into Oman, they get bigger and bigger and bigger. So some of them are well over 2,500 meters, well, even 3,000 meters in Oman. So you can actually go down and, you know, have freezing cold temperatures, even in the summertime when it's brutal hot in the UAE. And this is just a picture to give you a glimpse of what the mountains of the Emirates look like. You can see here there's a lot of diversity in the texture, the geomorphology. There's areas that are going to be more wet because they're at the base of these mountains in something called a wadi, which is a dry riverbed. But when it rains in these areas, that water gets into that gravel that's at the base of these wadis and will stay in there and serve as a water source for things like this vegetation that you have here. And just because of the unique geology of this area, the water, the microhabitats, because of the differences in topography and therefore temperature, you get a lot of diversity in the mountains relative to the rest of the Emirates. So the mountains of the UAE only make up 5% of the total area of the UAE. You might have noticed from the map, it's quite small, but it contains over 60% of the species of plants in the UAE and similar numbers of animals. So it's really a very diverse area. Mountains also conveniently make it very difficult for people to get in there and damage things with four-wheel drives, so that also helps. And just because of the unique nature of the environment there, we do have a lot of endemic species in the mountains. So these are species that only occur in those mountains and nowhere else on Earth. And obviously they're of extreme conservation value just because they're so isolated and therefore vulnerable. And just thinking through where these mountains come from, it really is plate tectonics. So Arabia and UAE is sitting on the Arabian plate. It's the world's smallest tectonic plate. And so it's been ripping off from Africa, as you can see over here. That's why the Red Sea formed. So it's sort of a tear in the Earth's surface, the Earth's crust, as the Arabian plate has sort of slid across, going towards the Eurasian plate over here. So across here, we have Iran and the Zagros mountain ranges, and the UAE is sitting here in yellow. And you'll notice right at the edge is where we get our mountains forming. And what's happening is the Arabian plate is getting subducted under the Eurasian plate. And so when you're looking at the mountains on the east coast of the UAE, what you're actually looking at is an uplift. And so you're actually able to see the crust and the upper mantle of the Earth by looking at the mountains in the UAE. And because there's very little vegetation, that sort of makes it a hotspot for geologists to come and look at the unique nature of the rocks that we have in that system. And so, for example, you can look at this purple here and this yellow that's over here and green. These are two different geologies. So this whole area is a type of geology called ophiolite, or a type of rock called ophiolite, which is an ultra basic rock. But the Hesburgite, I always say it wrong, here in purple, has a particularly unique geology that is super hostile to plants. So you see almost no plants in that entire area that's labeled in purple here, whereas it's slightly less hostile in this gabbro area that's in green and yellow here. And so you get more variation in vegetation in that area. But you do get specific ophiolite loving plants that will occur over in the Hesburgite and nowhere else in the Emirates, because they're quite adapted to that unique area. And so this sort of picture over here, you can see the reddish brown color. This is all uplifted mantle and crust. And so the crust is the part that's in the green and yellow, and the purple is the upper mantle, giving us that unique geology across the Hajar mountain range. And just to show you a couple of pictures, when you think of these wadis that are in the mountains of the UAE on the east coast, a lot of them look very austere and barren, don't look like they support a lot of life, but you're probably looking at a big wadi at the base of the mountains. There, when you get rainfall, you get massive flash floods that will rip anything that's there out, including your vehicles. So every year we have people dying when there's flash floods through these areas. And so you don't tend to get a lot of vegetation in these areas as a result. If you walk further upstream or drive further upstream into the smaller tributaries of these main wadis, what you do see then is vegetation starting to pop up, because yes, they get water, but not enough that it's actually moving all of the soils and ripping out the plants, for example. And what's going on in these wadis, you can see over here in a cross section and then a longitudinal section here. You know, when it rains, it'll run down the bedrock. So it's impervious. And so the water just runs down into these little basins. But the basins also contain that gravel, that alluvium that's been eroded off over many millennia, and it'll sink into that gravel. And so just under the surface of the gravel, where it looks absolutely barren, you have running water, especially after rains. But in some cases, it's running year round. And you'll occasionally get these outcrops of water whenever the bedrock sort of pops up to the surface again, and then it'll run underground and then pop back up where the bedrock basically acts as a sill and the water wells up over it. And there are 27 streams where we have permanently flowing water on the surface in the UAE, and they're really important because they support species of organisms that cannot occur anywhere else in the Emirates. So for example, these two species of fish that you have here obviously aren't going to survive without that water source, but even things that you don't think about. A lot of insects actually have their larval phase. So the most important part of their life cycle, where they spend most of their time, is actually underwater. Then they emerge and start flying and doing their business. And so they can't survive without this resource as well. So here we have the Hajar Mountains we were just discussing. North of that, we have what are called the Rus al Jabal Range, which is a completely different type of geology. So that's actually old, think of them as sedimentary rocks that were built up at the bottom of the sea just because of sediments building up, and then got uplifted as these mountains were lifted up. And so in this Rus al Jabal range, we have much higher mountains. They go up to 1,500, 2,000 meters, depending on where you are in these mountains. And so you get a lot different elevation, therefore different temperatures, different rainfall, and so on as a result of it, aside from the geology being different. So it's much more like limestone up there, much more attractive to plants and therefore the base of the food web. And you can see even the appearance of these mountain ranges is completely different. Amazing for hiking, amazing for cavers, because this stuff is very porous, and so water will eat away at it. And so we've got a lot of cave systems up in that area. But what that means is we don't have a lot of water on the surface. And so there's very little vegetation in this area, except in the areas where humans have gone in and actually set up seasonal farms, like you can see over here. So they've got this terraced farming area. They'll go in there and farm wheat and various other things during the summertime because it's at high elevations, it's cooler. And then in the wintertime, they'll go down and go back into the lower areas of the mountains. And then we also have these occasional outcrops that you can just see in these red dots here in the satellite imagery that we call the foreland ridges. They're made of the same material as the Rus al Jabal we just looked at. So bottom of the sea sediments that have been uplifted, but much more recent. And because of their unique geology, the fact that they're like 30 miles away from the main mountain range, they have completely different diversity than you get in the Hajar Mountains itself, supporting things like this butterfly here that only occurs in one part of the mountain range of the UAE in just 2 kilometers. That's the only place in the world that they occur. So obviously a very important conservation value. Off the side of the mountains, you get these what are called alluvial fans, where all these rocks have been eroded out over tens of thousands of years, giving us these big terraces of gravel you can see over here that eventually grade into the deserts a few miles away. And they support unique assemblages of plants. As you can see here, these are umbrella thorn acacia, the same type of acacia tree that you'll see if you go on a savanna in Africa. And they're using tap roots to get down through that gravel and access the permanently available groundwater that's coming off of the mountains throughout the year. And on a larger sort of scale, the UAE is also interesting, not just because of its geography and the unique environment that it has there, but really it's at a crossroads. So you have the Oriental system, the Palearctic, and the Afrotropical systems all exchanging organisms across this area just because of where it's located. But on top of that, it sits in this really arid environment that's called the Arabic zone. So you can see it's running across the Sahara and through Arabia and over towards Afghanistan. And all of that gives you really unique mixtures of biodiversity that are found nowhere else on Earth, just because it sits at this, this crossroad, this nexus. And so you can see various different organisms of multiple origins here. So plants that are well known from Africa but occur in the UAE. You can see here is this acacia tree and the desert broom that you can see here. The national tree of the UAE actually has its origin in Asia, areas around Pakistan. We also have, you may be amazed to know if you're from the Emirates or have spent time there, we have olive trees in the UAE that grow naturally in the mountains. So they're at very high elevations, very difficult to access, but they are coming to us from the Mediterranean. And then, of course, you have the hardcore desert adapted species like this white desert butterfly that you can see here, which you'll find all across the Sahara and into the Emirates. And we've been talking largely about geography here and not geology. And it's because geology is generally underground and not really important to life, right? But I'll talk about it just briefly because geology is obviously important for another reason in the UAE, and that's oil. So its economy is entirely driven off of oil. And what you have occurring under the UAE is these layers, these strata of this sedimentary rock that was building up at the bottom of the ocean. And that was building up many hundreds of millions of years ago. So think about 550 million years ago, the explosion of life that happened with the early eukaryotes. These were being laid down at that time. And so you had this marine snow of organisms that were aquatic, like algae that are floating around in the world seas that are sinking down to the bottom and then slowly getting crushed and pressure cooked over millions and millions and millions of years and turning into oil. And this material that we have here, you can see a picture of it in the north where it's really exposed and you can actually look at the layering. It's quite porous. And so as that oil formed, it can migrate through these cracks and crevices and eventually work its way up until it hits a salt dome. And so off the coast of the UAE, I'll show you pictures of these later, you get these salt domes that form where there's large pools of oil that are sitting under this salt and they can't get through the salt. And so they're sort of stuck near the surface in these big pockets that we then mine, of course, to get the petroleum products. So not really important for life, but very important for the economy of the UAE. And the only place that you can actually see the geology of the Emirates is the mountain systems that we just looked at over here. But one thing that you might find surprising if you've spent time in the Emirates is like you think of the Emirates as being covered in sand dunes, right? They're actually superficial. There's only on average about 80 meters of sand, and then you're into that bedrock like this underground. And so this illustration sort of gets across that point there that there's very little sand in the Emirates. And it's all been basically brought in by winds from central Saudi Arabia from the erosion there. So it's not even our sand. Okay. So switching gears, we'll talk about climate a little bit. So many of you probably recognize that the UAE is a desert if you spent some time there. But have you ever really looked at a map of the world and thought about, like, why is it a desert? Why do we get deserts in certain parts of the world? And the reason is because we have these large cells in our atmosphere that basically give us these patterns that are sort of repeated across the world. And you might notice if you look around 30 degrees north latitude, you have the Sonoran Desert, you have the Sahara, you have the Arabian Desert, and even parts of Pakistan are quite arid, and so on. And then if you look south, the Great Desert of Australia, the Namib Desert, the Atacama, and the Patagonian deserts are all at 30 degrees south. So what's driving this is these atmospheric cells that are called Hadley cells after the person who discovered them. And what's happening is if you think about the sun shining on the earth, where it's going to hit the earth the most and therefore heat it up the most is going to be around the equator, right? Because it's the center of the world, it's the thing that's closest to it. And so we tend to get most of the heat hitting the earth and being re-emitted is happening at the equator. And so if you heat something up, of course, it expands, it becomes less dense. And that's what happens with the atmosphere right at the equator. So it's heating up, it's getting less dense, and it rises. And so as it's rising, it's taking wind in from the sides and with that moisture. And so this air is coming in, rising up and bringing moisture with it. But of course, that at ground level, that moisture is vapor and you can't see it, but as it rises, it starts cooling. And eventually what you get is clouds as a result of that. And as those clouds continue rising, they're going to start condensing and you're going to get rainfall dropping out. And so all around the tropics, you'll see these cloud formations, and that's the area of the earth where we have our rainforest because it's constantly raining there as a result of this global process in these Hadley cells. But the issue is that we've now dropped out that rain and that air is still rising. So it'll rise up basically to the bottom of the stratosphere, an area that's called the tropopause, hits that, and it acts functionally like a glass ceiling. It hits that and then it stops and it has to spread because it's hit this glass ceiling. So some of it goes north and some of it goes south. And it carries along at the bottom of that tropopause as this upwelling air here keeps pushing on it. So it's pushing it up from below, moving it across. And where it falls down again, back to the earth, is at 30 degrees north and 30 degrees south, that band that we looked at just a moment ago, right here. And so you can see the UAE right here sits functionally right on that Tropic of Cancer, which explains why it's got this very arid desert environment that's there. You have to remember, it's not only dropped out the water back by the equator, but as it's coming down, it's heating up, which makes it even drier. So when that air is coming down on us, it is very arid, dry air. So very high evaporation rates. We also obviously have very little clouds because there's no water vapor in there. And so we've got an area that's got a lot of solar energy hitting it, hot, bright, no cloud cover, never rains. And that's us sitting there. Because of these sort of global scale cells, this drives the sort of wind climate that occurs around the UAE. And so I won't go too far into the details on this because it's a bit esoteric, but functionally during our winter time, which is the picture that's on the left over here, that high pressure zone basically drops down in the middle of Arabia. So that air that's falling functionally lands right here. But as it's coming down, it's getting spun because the Earth is spinning. So we have these Coriolis forces that cause it to spin around. And so you can see the winds around here all going sort of in a circle. But look at the Arabian Gulf or the Persian Gulf here. We have these consistent winds that are quite strong and coming down the Gulf itself. And so they're coming from the north-northwest. And so in Arabic, they're called shamal winds. And we'll use this term repeatedly, which refers to winds coming from the north. But even in the summertime, what happens is, you know, the cell is moving north as the Earth sort of wobbles with the seasons, right? Even in the summertime, we have that uplifting of air that's happening right here from basically the south of Yemen all the way through Arabia. So the air is uplifting. And so we've got this low pressure zone that's drawing in winds from the surrounding environment. And so you can see these winds are being drawn in from up by the Mediterranean, across Arabia and down to that zone, and then they're rising up. But you can also see this huge jet of winds that's over here in the Indian Ocean. Now that wants to go to the low pressure zone, but because of Coriolis forces, it's getting diverted. So it's getting bent to the right. And what we get as a result of that is the Indian Ocean monsoon. So that's what brings all the rains to India in the summertime and various other parts of Asia. It's just because of this little process that we have here. And again, you'll notice even here, we have the winds coming consistently from the north-northwest, same direction, just different cause. Aside from those sort of larger seasonal scale cycles in wind, we have every single day a very predictable wind. It's called a sea breeze. And so what happens during the daytime is we have the land over here. So in our case, it would be a desert heating up as the sun bakes on it. Now the sea is colder and the land is hotter. So what's happening is the air over the land starts rising and then it'll draw in wind from the sea. And so it'll pull in that wind from the sea as this is rising up. And you get these little sort of 30, 40 kilometer or 15, 20 miles, something like that. I don't think in Americanese, I'm sorry. These cycles of air that are constantly going. And so if you stand in Abu Dhabi and you face the coast on any afternoon after 1 o'clock, unless there's a weird storm system going through, you will feel a nice breeze that's cool coming off the water. I'm a sailor, so we use this every afternoon. We don't bother going sailing until 1 o'clock, and then we know we're going to get the best winds around 4 or 5 o'clock. Then the sun sets and they stop. And then slowly as the night occurs, the land cools down because there's no moisture there to hold the heat. So it cools down a lot faster than the sea does, and the opposite occurs, and you'll get a land breeze. So this wind that comes off the land going out to sea in the early morning hours. What about the temperature of the UAE? So anyone who spent time there knows that we have pretty hot summers and quite pleasant winters. So this is showing you a map of the temperature in January and the temperature in July, and this is in Celsius, of course. And you can see that we're hitting 45-ish degrees Celsius in the center of and this is an average over 24 hours. And so it gets much hotter. So our temperatures in the summertime, if you think in Fahrenheit, do reach 130 regularly. And so it makes it very unpleasant for hiking, I can say that, as well as sailing. But in the wintertime, it'll go down to something like even the low 60s in some cases at nighttime. And so extreme variation in the temperatures across the seasons, but you can even notice geographically there's variation because of the buffering of the water that's near the coast. The temperatures aren't nearly as variable there. The highest variability in temperatures across seasons or even during the day-night cycle will occur inland near these big sand dunes that we looked at earlier. So they'll get the most extreme cold in the winter and the most extreme heat in the summer. We have been looking, so we've been using the Area 5 data to model what's going on with temperatures in the UAE. And what we've seen is that there's been some incredible changes in temperature between the 1980s and 2010s. Now, from your perspective, it looks like every one of these numbers is just 1 degree Celsius. But if you follow climate change at all and the United Nations projections, you might recall that the number that they're really concerned about is 1.5 degrees Celsius, right? That's where we think there's going to be huge impacts on people as well as organisms. And so we are very near approaching that number ourselves today. Rainfall in the UAE is highly seasonal. So this is winter, spring, summer, and autumn. And you can see that most of the rain that occurs in the UAE is occurring in the winter time. And so right now we're going through a period of very heavy rain for the last month and a half or so, and then it'll stop and we'll have nothing until the fall. You'll also notice that most of the rain is occurring on the east coast of the UAE. That's where the mountains are. And so because of the elevation, it makes it easier for them to support rainfall. And in terms of the trend, this is very worrying. We have looked at the data from the 1980s versus today, or the last decade. And what we've seen is nearly a halving in the amount of precipitation in the UAE. So we've got temperatures rising, which is going to enhance evaporation at the same time that the rainfall is decreasing. Okay, and to close a bit on the marine environment. So I work on marine systems. This is one of the most fascinating places in the world for me to work because we have one of the shallowest seas in the world off of our coast. It's only 30 meters deep on average, which is not even as tall as this building, across the entire Gulf. Next door in the Sea of Oman, we go down over 3 kilometers, so like a mile and a half or so, a little more than. So really divergent environmental conditions as a result of that. The Gulf is also a very young sea. And so this map here is showing you the age at which the coastlines were formed. So during the last ice age, sea levels around the world were 120 meters below where they are today. And so there was no Gulf. If it's 30 meters deep and it was 120 meters, there was just a river that was today's Tigris and Euphrates running through a savanna system. And then it slowly started flooding in at around 18,000 years ago. You can see 12,000 years ago and so on. And the modern coastline that we have today is only 6,000 years old. And yet we brought all of these organisms in there that have had to adapt to the really extreme environment that we'll be discussing shortly. So I mentioned earlier when I was discussing the Ocean X mission about these mangroves that occurred off of our shoreline back 18,000 years ago at 120 meters depth. Still occur today, but are uniquely adapted to the environmental conditions here. On the west coast of the UAE, the dominant feature that drives things there is our winds that are coming from the north-northwest, those Shamal winds. The northern end of the UAE is a sandy coast, and so it gets the brunt of these winds because there's no shelter there. And so you get these massive lagoon systems that form as a result of that, very biologically important because they're so shallow and productive. When you go further west, you start to get barrier islands, places like Abu Dhabi, Saadiyat, and various other islands that basically provide habitat for organisms like coral reefs and oyster beds that used to be very economically important to the UAE. And as you look behind these barrier islands, so this is Abu Dhabi City, Saadiyat Island, and various others, you'll get these massive lagoons forming in the lee of these as well, obviously heavily developed by humans in recent years through dredging. And then even further afield, you'll see systems like we have over here that are very well protected by the Qatar Peninsula. So they don't get any wind functionally, no wave action. And so as a result, we get these massive salt flats that will extend inland for many tens of kilometers or tens of miles. Offshore, we have one of the world's largest seagrass beds. So we've got 4% of the entire world's seagrass beds just in Abu Dhabi state alone, let alone the rest of the UAE. And that supports things like dugongs. So these are similar to manatees that we have here in the States. So we've got the second largest population of dugongs in the world, and it's a critically endangered species. Further offshore around these islands, which are salt domes that have oil trapped under them, you'll get things like coral reefs occurring along their edges because they're providing a rocky substrate for these organisms. Now, in terms of the marine environment itself, this is the UAE up here on the bottom of the Persian Gulf. Every single summer, it becomes the world's hottest sea, which is why I work there. It makes it a really interesting place from the perspective of climate change. So your normal corals will be happy at around 80, I'm sorry, I gotta translate this in my head. Around 85 degrees Fahrenheit, corals will be happy. Around 90 degrees Fahrenheit, corals will be dying off because of bleaching. If you're in the Great Barrier Reef, largest reef on Earth, or the Caribbean. We have corals that are sitting at 98 to 100 degrees Fahrenheit every single summer. So a really interesting place to work from that perspective. And so you can see here this dramatic change in temperatures where we go from 18 degrees Celsius to 36 degrees Celsius, basically the same temperature as a hot bath that you draw in your home, with corals and fishes and various other marine organisms living in that environment. It's really crazy. But we do occasionally get events where the conditions go beyond normal and we get a super hot summer, a marine heat wave, and you'll get things like this. So 2021, during the pandemic, we had a mass die-off of green turtles, critically endangered species, as well as mass coral bleaching across the UAE as a result of temperatures that went up to several degrees more than even the extremes that they normally have. As a result of the extreme temperature, we also get a lot of biological activity that's demanding oxygen from the water, as well as the water, when it heats up, doesn't hold oxygen very well. So we also get occasionally low oxygen or hypoxic events, which are a further threat to marine organisms in the UAE that we're just learning about. And it's also, because of the high evaporation rates here, a super salty basin. So we have normal oceanic salinity is 3.6% salt. Here we're at 4.4% salt, so a good 25% more salty than you get in your typical ocean systems. And then we have those weird shamal winds that are constantly running across the Gulf, and because it's shallow, they'll stir up the bottom. And so you get large areas of turbid water when the bottoms get stirred up as well. So really a stressful environment for marine organisms. But shamal winds can also have a benefit. So when you think about, you get a coffee from the shop, it's too hot, what do? You blow on it, right? But you don't probably think about what you're doing. What you're doing is what's called latent heat flux in physics. And so you're literally using evaporation to pull heat out of your cup. You think of it as getting water vapor out, but it's not. You're pulling heat out of your cup. And when you think about these shamal winds blowing across the Gulf during the summertime, they're doing the same thing at scales of thousands of kilometers. And they will pull a huge amount of energy. So we've calculated in a square meter, it pulls out the equivalent of what your wall-based air conditioning unit does in your home. So it's a huge amount of energy pulled out in just 24 hours if you have good shamal winds that are running across this. And so if you don't have shamal winds, temperatures can build up to lead to things like coral bleaching. Or if you have a good summer and there's relatively consistent winds, that'll keep the temperatures low enough that we don't get coral bleaching. Now the Arabian Gulf, as I mentioned, is super shallow. You go over to the east coast of the UAE here, and the water is extremely deep off of the coast. And as a result, we have a much more benign environment over there that's more typical of oceanic conditions. And so temperatures in the summer and the winter are a good 2 or 3 degrees. So that's about 10 degrees different in Fahrenheit from what you get in the Arabian Gulf. So it's much cooler in the summer, much warmer in the winter, and therefore supports a lot of diversity of things like, we have highest diversity of corals, fishes, and various other things on the east coast of the UAE because it's so benign compared to the Gulf. And we also have things like monsoons and tides that really drive the marine environmental conditions on the east coast of the UAE as well. So this is a picture showing you what happens during the monsoon. So we've got the monsoon blowing up the coast of Oman this way, and that pulls this deep water from the bottom of the ocean up against the coast in a process called upwelling. And so we get this cool water that's basically coming up at the hottest time of year and cools things down. And that will extend up here along the coast of the UAE as well, which is right there. And so you can see here in the Gulf from June, July, August, et cetera, it's getting hotter and hotter and hotter in the Gulf itself and starts to cool down in October. But if you look at the east coast of the UAE, there's these fingers of water, cooler water that are coming in because of the monsoon that are keeping the coastline on the east coast of the UAE much cooler. And then on shorter time scales, every 6 hours, we've got this tide that's flushing in and out. And because there's deep water next to these islands where we've got all of these coral reefs, they'll spill some of that cool water over the surface and bring down the temperatures to something much more moderate. And then the East Coast, because it has these rocky promontories that are occurring because of the Hajar Mountains, we also get amazing coral reef development in that area. How am I doing on time, Mike? Soon? Okay. And so altogether, what that gives us is this stage, that physical environment, our geology, geography, our climate, and the marine systems that all work together to give us this array of organisms that call the UAE its home. And so that's sort of an intro to the book. The various other components of this book look at the ecosystems of the Emirates in the second section. So we look at the vegetation across the UAE, the mountains specifically because they're so unique in terms of the diversity, the massive stands of mangroves that we have there, which are important as blue carbon sinks, and the lagoons, very important in terms of biodiversity. Then we go underwater and explore things like oyster beds, coral reefs, seaweed beds, which nobody really thinks about, but are incredibly important as a spawning habitat for things like fishes, and then seagrasses, which support our endangered green turtles as well as our dugongs. So we have a chapter written on each of these. We then move from the ecosystems onto organisms, looking, for example, at these terrestrial organisms here, our birds. We are a major site for migratory birds coming from either Asia or Europe down to Africa and vice versa through the seasons, as well as these other organisms. And then moving into the sea, looking at things like our fishes, our sharks and rays, or cartilaginous fishes, and even marine mammals like whales, dolphins, and so on. So there's chapters on each of these. And this has to be the best picture in the book. Johannes Ellis took it. This is a sea snake nailing a fish. And then we close the book with a section that's on humans and their place in the environment, because of course we're a critical component of our environment nowadays, right? So we look at this from a historic perspective in terms of how humans existed in this environment before air conditioning, which is really remarkable when you think about it. And then today, with our cities becoming ecosystems that are being used by commensal organisms, and the microhabitats that we're providing them, the food sources and the water sources and so on. And we close the book with a forward-looking chapter called The Emirates at 2050, which is basically looking at the challenges that these amazing ecosystems and organisms are experiencing as a result of our activities, and what the UAE is going to look at like at 2050 if we don't make some changes. And so we close that chapter looking at 10 policy recommendations for decision makers in the UAE to consider that might stem the decline. And with that, I will close by thanking our government partners, Tamkeen. So Tamkeen very kindly paid for this book to be open access. So we published it with Springer. They're a great organization to work with, but Tamkeen is what really got this book past the final stages. So they've provided us the funding so that anyone can, with a phone, a tablet, a laptop, anywhere in the world, can go and look at individual chapters of this book, download them as PDFs, share them with their friends, and use them as educational materials. We also made it Creative Commons licensed so that every single picture that's in the book and every single line of text that's in that book can be used by anyone for any purpose. And I'd also like to thank Mubadala, Dalio Philanthropies, who also supported us in terms of the Ocean X mission that I mentioned at the start of the talk, and of course my employers at NYU Abu Dhabi, for whom this book was written. All right, thank you very much.